My name is James Millington. I'm a lecturer in physical and quantitative geography here at King's College London. I've held this position since September 2013. Today I'll be talking about how we can use simulation models to understand the geographical world. So my research uses computer simulation modelling tools to investigate spatial, ecological and socio-economic processes and their interactions. Geographical patterns are often produced as a result of interactions of many different and potentially unique elements. These elements might be trees with particular environmental resource requirements, or they might be people with different goals and aspirations. And the diverse range of interactions between these elements can make it quite difficult to understand the causes and consequences of the patterns that they produce, of the temporal dynamics as well. But by representing the real world in a computer simulation, we can explore the multiple aspects of the spatial and temporal dynamics of these systems that are of elements that are interacting. So in my research, I represent the geographical world using what we might call reduced complexity simulation models. And these models focus on the dynamics of the system rather than the details. For example, cell automata models represent the world as a discrete grid of cells or pixels, and each of those cells can have a certain state and follow rules of change dependent upon their own and their neighbours' cells' states. So one example of this is the forest fire cell automata model. As you can see in this visualization, we're adding trees to this landscape here. These are the green pixels. We're also adding matches that if they land on a tree will burn them. The fire then may spread through neighbouring trees. So for example, there was a really large fire as a match landed on a single tree and it spread through the network of contiguous adjacent trees. So I've developed and used models like this with a more detailed representation of the impacts of environmental conditions on vegetation, establishment, growth and mortality. In this example, we're just adding trees randomly to the landscape. But when we have these more detailed representations, we can explore how the interactions of climate, vegetation and fire might play out under future scenarios of different climate change. As you can see from this example, we've got 9 schools with parents of varying attributes, and that's shown by how dark or light in colour they are. The simple rules of interaction between them means that the starting situation is random, but through time we start to see patterns of neighbours with similar attributes grouping together. The advantage is with this type of modelling we can examine scenarios. So now you can see one of the schools has been removed in the bottom right there. And we can see how these interactions through time now result in different system dynamics now that that school has been removed from the environment. The geographical world is complicated and often complex. Using simulation models like those I've just shown allows us to compare the consequences of the assumptions we make in the models with the real world. We can take data that we've collected out there and compare the two. That helps us to understand how the geographical world functions. Hopefully it can also help us make better decisions.